So in Module 10, we finally meet expressions that are called radicals, radical expressions, of which the square root is one type. And in general, there are roots of all indices that we would want to deal with. So just really quickly, before we talk about this specific example, I want to make sure that we're all speaking the same language when it comes to radicals. So if I were to write down this funny radical symbol and put a number underneath it, let's say I put the number 64 underneath it, then how would you interpret what that quantity is? Square root of 64, what does that mean? Well, yeah, okay, so that's what it is. What it is 8. What does it mean, though? How do we know that the square root of 64 is equal to 8? Give me a rationale for that. What's the because? The square root of 64 is 8 because 8 squared, in other words, 8 times 8, is equal to 64, right? And be careful when you read equations like these in your own head, okay? Because I'm convinced, and I think there's some research to show this, that one of the chief misunderstandings that people have around this material is because they are not, in their mind, using proper terminology for them. So on the right-hand side, on the second equation, what I have is 8 squared. That's what we mean by 8 times 8. On the left-hand side, in the first equation, what I have is not a square, but a square root. And sometimes when people are reading these things in their head, when they're reading a square root, their mind keys in on the word square, and it misses the word root. And so sometimes what will happen is that you'll conflate the two of these things. You'll see a square root and you'll think of squaring, or you'll see square and think square root, which is less common. But you'll see a square root and you'll say, oh, square root means multiply by itself. But that's a different thing. In fact, it's completely the opposite thing. The square root is the opposite operation to squaring. The square root of 64 is 8 because 8 squared is 64. So 64, the square root brings you to the smaller number 8. The square, the second power, brings you back to 64. So whatever squaring does, the square root undoes. If I want to solve the equation square root of u plus 2, quantity minus 2 is equal to 3, then just to remind ourselves of what exactly is happening to our poor variable u here, according to the order of operations, which evaluates an expression from the inside out, the first thing that's happening to u is that we're adding 2 to it, and thereby getting the quantity u plus 2. So that's what we see here. Subsequent to that, the value that we get is then square rooted. So we have the square root applied to it, which doesn't mean multiply it by itself. It means do exactly the opposite of that. Find the quantity, the number, which when multiplied by itself gives us u plus 2. So that's wrapped inside of the square root. And then that quantity is having 2 subtracted from it. And so we're wrapping it in one more layer of wrapping paper here to build the expression u plus 2 under the radical minus 2 that we see on the left-hand side of this equation. So if my job is to solve for u, I want to unwrap this equation. And the same way as we always do, the unwrapping has to happen in the opposite order as the wrapping did. The outer layer of wrapping paper has to get peeled off first before the inner layers can get peeled off. So what do you think should be the first thing that we do on both sides of this equation to try and get our wrapping paper removed? What do you want to do first? Outside layer is to subtract 2. How do we undo that outside layer? What's the opposite of subtracting 2? Adding 2. So our first move here is that we want to add 2 to both sides. If I add 2 to both sides, then on the left-hand side, I'm just going to have the square root of u plus 2, just the square root of x, u plus 2 on the left-hand side. U plus 2. Now on my right-hand side, I have 5. So far, so good. And now that our outer layer has been taken care of, we have the next layer on the inside. We have the green box, the green layer of wrapping paper, which is our square root. And according to what we talked about over here, how do we undo a square root? What is the opposite of taking the square root of a quantity? Yeah. So the opposite of taking the square root of a quantity is squaring that quantity. Well, maybe that's worth writing down in words here. The opposite of square root as a verb is square. In other words, raise that quantity to the second power. Multiply it by itself. So if I'm going to undo this square root, what I want is I want to square both sides of the equation. If I square both sides of this equation, that will make the square root go away. So I'm going to square this, I'm going to square that. Now my square root and my square, those are opposite to one another. And so the net effect is that the square root is gone. But the right-hand side, which used to be 5, is now 5 squared. And 5 squared is 25. That was the key step in this process. Knowing that to undo a square root, what we really want is we want to square. We want to raise both sides to the second power, or equivalently, multiply both sides of this equation by themselves. That kills our square root and leaves us with just u plus 2. And now this is an equation that we could have solved months ago. To get the u by itself, finally, we just need to undo the addition of 2 by subtracting 2 from both sides. And so what I end up with at the end of this problem is I end up with u equals 25 minus 2. U equals 23. So there's the solution to this equation. And of course, we should always check, anytime we solve an equation, we should always check to make sure that our solution actually works. It's especially important when we're dealing with radicals, square roots, in these kinds of problems, because sometimes these checks don't end up working out at the end of the day. So let's make sure this one does. If I replace u with 23, then I'm supposed to check that 23 plus 2 under the radical minus 2 is equal to 3. And again, order of operations works from the inside of our grouping symbols outwards. So underneath the radical is the first thing we do. Square root of 25 minus 2. What's the square root of 25? 5. And 5 minus 2 is in fact 3. So we did find a solution to this equation. And again, going back and looking at this, the key step was, first of all, isolating the square root, getting it so that the square root was the only thing happening on that side of the equation. Notice the first thing we did was not square both sides. The first thing we did was unwrap that arithmetic which was happening outside the square root first, so that all that remained on the left side of the equation was the radical quantity. Then when we square both sides, the radical goes away, and we're back to the kind of equation that we knew how to solve back in September.